Hi, welcome to my Trivium Homeschool Chemistry class. Today we are going to continue on learning about how to balance equations, but before we do, I would like to review just a little bit from what we learned in our previous lesson. This way there's just some things that are highlighted that we can add to our lesson today and help it come along better. Okay, also we are studying out of our textbook, Exploring Creation with Chemistry by Dr. Weil. It's the Apologia, second edition. If you do have questions, please refer to page 120 to 124. Also, you will be finding your homework assignments on your own on page 124. You will do both 4.6 and 4.7. Okay, in review then, we have our chemical reaction. It is written carbon plus oxygen yields a carbon dioxide. Chemists do not use words to write out their problems because they're too bulky. So we abbreviate them, and thus the name changes to a chemical equation. Up here we have carbon plus oxygen equals carbon dioxide. Let's remember that the numbers to the left of the arrow are the reactant side, because those are the substance, the atoms and molecules that will react together. And on the right side of the yield sign is the product side, which says that those are the atoms and molecules that are being produced by this chemical reaction. Down here in our steps we have step 1, which is a carbon atom and the two oxygen molecules. When they react together, the oxygen molecules will split apart, and then it recombines to form a whole new molecule, which is O2. And down here we have that example. We also learned about the combustion of methane. We start with our reactants, which was CH4 and 2O2. And the oxygen molecules will split apart into two oxygen atoms, making a total of 4 oxygen atoms. The methane molecule splits apart into 1 carbon and 4 hydrogen atoms. Here we have the example of it. Again, step 3, they all recombine, no problem. The atoms recombine, they form new products, and this is our end product. We have CH4 plus 2 oxygens equals, and here's our 1 CO2 and 2 water atoms. Okay, we're going to move on. Now, remember, we learned something in algebra. We learned that like terms you can add together. X plus X equals 2X. Same thing in chemistry we talked about. So really, at the end of our problem, we had CH4 plus an oxygen molecule and an oxygen molecule. We could add oxygen to oxygen, and we got 2 oxygen molecules. And we also, down here, had water plus water equals 2 water molecules. Hence, we just simplified our equation. Methane plus 2 oxygen molecules yields carbon dioxide plus 2 water molecules. Okay, review. Now, today we are going to start with our new concept. We're going to start with balancing our equations. We know that by the law of conservation, that the law of mass, that our problems have to be equal. Otherwise, they will be unbalanced. So, as we go through for this now, let us continue to keep track of the atoms in each side of our equation, on the reactant side as well as the product side. They must be the same number. For example, if I had 5 hydrogen atoms on this side, I would have to have 5 hydrogen atoms also on the product side. Okay, otherwise it does not balance. Let's see how this works using our methane combustion example again. Up here, what we do is we have our reactant side. Let's count the number of carbon atoms on the reaction side. To do this, you must first take the number to the left, which there is not a number to the left of our carbon up here, and multiply it by the subscript. To do this, so what you would do, we would say, okay, there are no numbers to the right of our C, so that this we assume to be 1. We also look at our numbers in the subscript. There are no numbers in the subscript, so we say there are also 1 there. 1 times 1 is 1. Next, we look at our carbons in the carbon dioxide molecule on our product side. We look to the left. There is not a number to the left of this, so that is 1. We look to the number to the right and see if there's a subscript. There is no subscript there, so that is 1. Okay, 1 times 1 is 1. Our carbon here is 1. Our carbon here also is 1. Now we're going to move to the hydrogen. Hydrogen we look to the left. There is not a number to the left, but there is a number to the right in our subscript, so it is 1 times 4 equals 4. Let us look over here to the hydrogen. We have the hydrogen. We have a number to the left. This time the number is 2, so we are going to put down the 2. We look directly to the right to determine if there is a subscript, and there is. There again it is 2. 2 times 2 is 4. Our hydrogen on the reactant side is 4. Our hydrogen on the product side is 4. So far we're balanced. Good job. Now we're working on the oxygen, the reactant side. Let's see if you can help me out do this. We have 2 to the left, which is our number down here. We have 2 in the subscript. 2 times 2 is 4. Good. Now, to figure out the total number of oxygens on the product side, we first have to determine how many oxygens come from this total. There is no number to the left of our carbon dioxide, so that gets a 1. There is a subscript of 2 to our oxygen, so that is 2. Our water, we have a 2 because this is a molecule. This signifies that this has a number in front of it as well, so that is 2. And our number to the left in the subscript is 1 because there isn't anything. 2 times 1 is 2. When we get to this part, we have to add 2 plus 2 to get 4. That's a little tricky and it gets a little tough, but I think you understand that you break them down, and the more practice you get with these, the easier it'll get. So 4 and 4. This is a very balanced equation. Let's move to our next equation. We have this big fancy equation up here, and just for the namesake, we're just going to brush through this quickly. Here again, we have the reactant side. 2HCl plus CaBr2 yields to 2HBr plus 2CaCl2. We're going to start with the reactant side. Our hydrogen, we have 2 to the left, times nothing right here in the subscript. It is 1. 2 times 1 is 2. Our product side, we have 2 hydrogens to the left, nothing in the subscript, so it is 1. 2 times 1 is 2. The hydrogen's balanced, that's good. Now let's look at the chloride. We have Cl, we have 2 to the left, because remember, this is a molecule. We have 2 of them. And we do not have anything in the subscript, so 2 times 1 is 2. Over here, we have 2 in the molecule here, and then we have a subscript of 2. 2 times 2 is 4. Okay, this signifies right away that this Cl equals 2 and this one equals 4. Right there, you know that this is not a balanced equation. But if you go through the rest of the problem as well, taking the calcium, taking the bromine, taking the calcium, they do not balance out either. So this is an unbalanced equation. Now you'll understand that. Now, our last equation, just for practice sake, I'm going to walk you through this one more time. Let's see how you can do, how well you're doing this together. We have 6 CO2, and we have plus 6 water molecules yields 6C6, hydrogen 12, oxygen 6, plus 6 oxygen molecules. Okay, step by step, take the reactant side first. We have number to the left of this carbon is 6. 6 times 1, because there is a subscript there, it is 6. Our product side. We have carbon here. There isn't a number to the left, but we do have the subscript, so it's 1 times 6 equals 6. They're balanced. Are you guys with me? Let's go to the oxygen. We have an oxygen molecule. Since it is an oxygen molecule, we look to the left, and that left is 6. We have a number to the subscript, that is 2. 6 times 2 is 12. We will add, because we have more in this equation, we will add now this number to whatever this might be. So, again, 6 oxygen molecules, nothing to the subscript, 6 times 1 is 6. So 6 plus 12 is 18. We have 18 as a balancing number here. Again, we'll go over here to our oxygen. It is 1, because we do not have a number anywhere to the left. And we do have a subscript, that is 6. 1 times 6 is 6. There again, we have a 6. 2 in our subscript, so 6 plus 12 is 18. Our oxygens are balanced. And again, to the last, we have 6 times 12. I'm sorry, hydrogen is 6 atoms to the left of the hydrogen, and 2 in the subscript is 12. Our hydrogen is also 1 hydrogen, 12 in the subscript, also 12. This is a balanced equation. I think you guys got the hang of it now. Good luck, and thank you.